Hey guys, now that we've understood the concept of micropartitions, clustering and clustering keys, let's see it in action. So I'm back into my trial account, Snowflake account, and I'm gonna click on the same database, Snowflake sample data, and I want you guys to open up the schema that we've already dealt with, PPCH SF1000. So let me go back to my editor. By the way, the code for this can be found in the resource section or in the GitHub link, which was shared earlier. I'm going to set the schema by saying use schema database name dot schema name. Now let's have a look at the table line item. We've seen this before. If you hover over the table names, it'll tell you it has been clustered using a clustering key, right? If at all it has been clustered. Now there are two ways of understanding your clustering information of a table. Now the first one is by using your inbuilt system function. Now any function that starts with system dollar means it's an inbuilt function. So the function clustering underscore information can be used to identify your clustering information. So let's execute it. It takes two parameters. The second one is optional, the second one being your clustering key. But since the table is already clustered, it's going to tell me that, it's not needed. It's optional in this case. So let me execute it and click on the result set. So it tells me it has been clustered by using the column L underscore ship date. The next parameter tells me it has this table line item has 10,336 micro partitions. Okay, it's pretty straightforward. The parameter total constant partition count is the number of micro partitions that will not have a significant impact as a result of reclustering. Now, reclustering, as the name suggests, is the process of clustering your table as and when the data arrives. So let's say you have a table and you have 5 micro-partitions inside of this table. Now new batches of data are arriving and being ingested into this table. Now what happens here is that Snowflake, using its brain, which is the cloud services layer, will try to identify which chunk of this new batch of data that has arrived goes into which micro-partition. Okay. As a result of this, some of these micro-partitions will have the need to be reclustered, but there will be some micro-partitions which will remain untouched. Okay, which basically means these micro-partitions can remain as is. They will not have any significant impact as a result of reclustering. Maybe because they've already maxed out in terms of the size of data that each micro-partition can hold. Right? If you remember, each micro-partition holds data in the range of 50 to 500 MB of uncompressed data. So if it's already 500 MB, if it has maxed out, then that micropartition will remain as is. So this is the number of micropartition that will not have any significant impact from reclustering. Now, how do you interpret this value? You can think of it as a value if it is as close to the total number of partitions as possible, the better clustered your table is. So the higher the value, the better it is for your table. So 8349 out of 10,336 is a pretty decent number. You have 8,349 micropartitions that are constant. They will not have any significant impact. If you see a number, if you see a relatively smaller number, let's say 0, 10, 100, considering the number of partitions you have, you might have to reconsider your table model. So the next, average overlaps, average depth, partition depth, and histogram, will be covering these three in once we understand the concept of overlapping and clustering depth. So we'll keep that for later. For now, let's close it. You can also say show tables like lined. So right now we are focused on the table line item. So if you execute this command, it'll give you the basic information. It'll tell you that this table has been clustered by the clustering key and few other details which we'll be covering later on. But you can see the automatic clustering is on, which means this table will be automatically clustered as and when the new batches of data arrive into this table. You can turn it off, but we'll look at it later. Now let's focus on firing a few queries now. So let's say I want to select from this table line item. I'm not using the clustering key. We know the table has been clustered using the column L underscore ship date, but I'm not going to use it. Now, before I execute this query, what I want you guys to do is maybe create a new warehouse. So right now the default one is selected, which is compute underscore WH, but I want to use a different warehouse. So I'm just going to say, I'm going to set that in context as well. I have already created an Excel warehouse. You can click on warehouses and feel free to create uh, an upgraded warehouse, which is pretty, let's say, large or extra large in size. So I've created a large one and it's a single node, a single cluster warehouse. You can see min is one, max is one. And this is what I'll be using. So I'm writing a simple query, select star from table name, right? I do not need to actually specify the database in the schema name. So let's say I say limit 20,000. Okay, now took 2.2 seconds. Okay, now let's click on history. Now this is the tab that's very important. It'll show you the history of all the commands that you've executed. If you're an account admin, you should be able to see literally everyone's history in your organization. Uh, let's click on the query ID against the query that I executed most recently. So I'm going to click on that, which is select star from line item. I'm going to click on the profile tab up here. Now let's focus on the profile overview. It tells me I scanned one partition. The query select star from table just scanned one partition out of the total partitions that we have, which is 10,336. This is something we've seen before. The byte scanned is 765 MB, which is okay, considering the fact that the query only scanned one micro partition, right? Now, let me click on history again. I believe I ended up running this query in the small warehouse. So let me go back. I'm going to say use warehouse. Now my warehouse has changed. Also, if you're trying to benchmark your query performance uh, against huge tables, it's good to use this command every now and then. I'm saying alter session set used cache result is false. Now, every time I run this query, my cache is going to be cleared. So the result of your query is not going to pull from your cache, but it's actually going to execute it against the data, the stored data. So I'm going to run this and I'm going to run the same query again, just to be sure, in the large cluster. So you can see it took 1.65 seconds. Now let me click on the query ID. Now there's a faster way of getting to this page is by clicking on the query ID. Now you can see the partition scanned is 9. So you can ignore the first one I fired. I think it pulled out the result from the cache. It scanned 9 partitions out of 10,336 possible partitions. The byte scanned, which is 3.5 GB, which is okay. Now let's go back and try to increase the number of rows. Now you'll realize it'll scan more number of partitions. Ideally it should, unless 50,000 rows existed within the 9 partitions. So I'm executing it again. I'm going to click on the query ID. So you can see the number changed. When I set limit 50,000, it ended up scanning 14 partitions. Now let's go back and now let's use the clustering key. I believe I already have a query here. I'm just going to take the where condition. I'm going to say where L underscore ship date is this value. And let me actually limit it to 10,000 rows. It took 879 milliseconds, but let's see how many partitions did it scan. So you can see it scanned just one partition because this key is a clustering key. It has been used while clustering the micro partitions. Let's do another thing. Let's add another date here and see. Now, instead of saying ship date is equal to, I'm going to give it another value here. Let me take this value and run the same query again. It took 713 milliseconds. Well, lucky enough, it just ended up scanning one partition again, which is not bad. So I hope you guys are getting a hang of what's happening here. That there's a difference when you use a clustering key as opposed to not using it. Now let me go back to my editor. Let's look at another table, which is pretty interesting. The name of the table is parts up. You've seen this table before. It has 35 GB of data and it has been clustered using the column ps underscore supply key or sub key. Okay, let's preview this table. So you can see the result here. Now, we know this table is already clustered using the key ps underscore sub key. So let me get rid of that optional parameter. Now, this is pretty interesting. This tells you the clustering key used, which we are already aware of. But you see there is a note parameter here. It says clustering key columns, the one used, the clustering key column contains high cardinality, which might result in expensive reclustering. And they've shared the link to the documentation. Now, I want to talk about the cardinality here. So let's go back to basics. I hope you guys know what cardinality means when it comes to database systems. Now, the way, if you do not know, cardinality is the number of distinct values of the column in question. So if the number of unique or the unique count or distinct count of a specific column is extremely high, you say the cardinality is high. If it's low, you say the cardinality is low. Now, turns out this column ps underscore supply key or sub key has a very high cardinality, which is not good. If you think about it, let's say I have a million rows in my table and I'm selecting the column which has a distinct count of 5 million rows. This basically means I'm telling Snowflake create 5 million micro-partitions, which is a terrible decision, to be honest. So this is a bad decision, but don't worry, this is not something we chose to do. This is a table which Snowflake has provided us with, just I believe, so we understand the concept of clustering. Now, with that being said, let's also check the distinct count. So what I'm saying is select count of 1 is basically selecting the count of rows, and select distinct ps underscore sub key, which is the clustering key in this table, right? From this table. Actually, I don't need the database and schema name. So you can see it has 80 million rows and it has this key, this column ps underscore supply key has 10 million unique count. So this is not a great decision. In such cases, what you would do, or what one should do, is not cluster the table at all, because if you see 35 GB is not a huge amount. It's not a crazy amount. So sometimes it's also good to not cluster the table at all. But we'll be understanding the key considerations when it comes to clustering your table in one of the later videos. For now, just know that high cardinality is a bad decision, is a bad candidate for your clustering key. So let me change the schema. Now you remember in one of the earlier videos, we ran a bunch of SQL commands. We created a new database, e-commerce underscore DB, and we copied all of the existing tables from the schema into our e-commerce underscore live schema, right? What I want to do is change the schema to e-commerce underscore live. Now I want you to hover on each of those tables. You'll realize something. Let's say the table parts up that we just saw. This table Turns out when we just created this table using create table as select as using select as, this does not copy your clustering key. Okay, so if you create a table using select star from another table, this will not clone your clustering keys. That's pretty much how it works. In this case, you will have to actually recreate these tables using a simple intuitive SQL statement. What you can do is, let's say you want to create or recreate the table line item here. So what you have to do is say create or replace table line item. You should say cluster by ship date, because I want you guys to recreate each of these tables using the exact same clustering keys that we've used. So I want you to run this command. I've already done it, so you can see my line item has been clustered, but in your case, it will not be clustered. But before you execute this command, I want you guys to upgrade your warehouse. This is a large one, but if you recreate each of those tables inside a large cluster, it's going to take a while, probably more than 10 minutes, let's say for the table line item. So what I would recommend is click on your warehouse, configure it, and scale it out, or rather scale it up to 3x large or 4x large, only for this purpose. And then you can scale it back down, okay? So you can pause the video now, recreate each of these tables. Try to not copy paste the commands from the resource section. Try to do it by yourself. It's pretty straightforward. Also, you can actually use these SQL statements. It'll come in handy if you want to scale up and scale down your clusters, or sorry, your warehouses. So play around, look at the tables. I'll be explaining the relationship between these tables in detail when we actually get to the SQL part of this section, where we'll be writing transformation and aggregation SQL jobs. So next up, we'll be understanding the benefits of micro partitions and clustering in theory. So I'll see you guys there. Thanks for watching.